Bismillahir Rahmanir Rahim. Chapter 20, Unicast Routing. Before we begin with the chapter, I want to highlight some important points about the slides that I have uploaded on Blackboard. We have two sets of slides. There is Chapter 20, 2016 with extra basics material. In this you will find some additional slides. These are the slides we took in class, and they explain to you about direct delivery, indirect delivery, hierarchical routing, how to make routing tables, things like that. Basic material which I feel is necessary for you to understand the topic. Chapter 20 based on syllabus. Now these slides contain only the slides that are relevant to your syllabus from an exam point of view. So this presentation will have additional material which is useful for you to understand, but you will not be tested upon in the exam. Whereas these slides contain only the syllabus that you will need for your exam. Having said that, let's begin with the chapter itself. So in this chapter, we're looking at unicast routing. As we know, on the internet, we have a huge number of computers, of routers, and the IP address that we have gives these devices an address on the network. But what we need to know is how can we move a packet from a source in one network to a destination that is in another network. We do this with the help of routing. And just quickly looking upon the concept of direct and indirect delivery, when we have the source and the destination both located inside the same network, it is called direct delivery, because in this case we are not in need of any routers, routing tables or forwarding tables for the packets from this host to go to the other host. Delivery of information is straightforward in this case. The packets don't need to go outside the network. This is the gateway router for the network. But because the source and the destination are both inside the same network, we don't need to make use of this gateway router. This is direct delivery. In indirect delivery, we have the source and the destination both located on different networks. So this is one network. You have the source connecting to its gateway router, and on the other side you have the destination also connected to its gateway router. So when the source sends the information to its gateway router, this delivery is direct delivery, okay? Direct delivery. Because it is the same network. Actually, the network would be the same until here, not this interface. This interface would belong to another network. But this side would be the same network. So it's direct delivery. Similarly, in this case, we have from the router to the destination, again, this is direct delivery. Now the information from the source router, the source gateway router to the destination gateway router, this information will move across the internet. and it will move between different routers. Okay, so this part will be indirect delivery. So this is how we recognize where we need routing tables. It is in the indirect delivery side of the network or the internet where we need routing tables, because this is where we don't know how can we move the packet from this router to the destination router. There needs to be a mechanism, and this is given to us by different routing protocols. And we are looking at unicast routing protocols in this case. We looked in the class about the concept of hierarchical routing. It says in the slide that unicast routing between a large number of routers and a large number of hosts on the internet can be done only by using hierarchical routing. Hierarchical routing was also explained in class using these slides. And we showed here the example where we have the network address 120.14.64.0 with a subnet mask of 18. We now see that this address with a subnet mask of 18 can provide us with a total number of hosts 16,384. So these are the number of hosts that we can accommodate in this IP address with this particular subnet mask. So the subnet mask, if we were to draw it, it would be 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, and 2. Right? So we have 16 plus 2, which is 18. So this part of the IP address .14.64.0. So we have this part, these bits in the address will represent the network bits, and the rest will be the host bits. So which means all these hosts in this number we can accommodate 16,384. Now the question comes, we cannot simply assign random addresses to devices. They must be done in a systematical manner. In this case, we had the example of Mobily as the service provider. We are taking an example, and we are saying that we have the head office that has been given this IP address to use for some parts of its customer base. So what Mobily does now, the head office now is going to divide this big address into 4 sections. Okay, so we have in this case a set of IP addresses 16,384. We have divided these IP addresses into 4 regions. Okay, the north, east, south, and west. And we're saying we want every region to have 4096 hosts. This is what happens when we divide this by 4. And how do we achieve this? We take this address and these 2 bits that you see, we will use them as network bits. So now the subnet mask here has become 20. Of course, the number of hosts that we can now accommodate is less, 4096, but we have a systematic division of these large number of addresses. So we now know that any device that has a network address 120.14.64.0 with a subnet mask of 20, let's say, belongs to the northern region. Similarly, we can say that just by looking at the IP address and the subnet mask, we know now which region this belongs to. So these are the regional offices. This is how they have divided the IP addresses. Now each regional office will also take the IP address and further add to it more subnet bits. So here we had 20 and now we are having in here 23. Okay, so we are taking 1, 2, and 3. So we are having a subnet of 23. The number of hosts has also gone down to 512. But as you can see, there are more branches. So in this case, again, we are basically taking this and dividing it into smaller regions. Okay, so these will be 512, 512, and so on. So this is what's happening in this case. What is the advantage of doing all this? We still know that what the total number of hosts in this region with this IP address is 16,384. All these hosts will be recognized by the same base network address with a subnet mask of 18. Okay, so if we have a gateway router here, the main gateway router, and when this router is connected to, let's say, the network in this way, any traffic that comes in for these 16,384 hosts, this router will have only one entry in its routing table. Because it knows that any packet destined for this network 120.14.64.0/18 will all go on this interface. So instead of having all these many addresses in its routing table, we have shortened the entries in the routing table by intelligently designing this in a hierarchical manner. So this is hierarchical routing, and this is what happens with addresses. So in this case, we are saying that unicast routing in the internet is done using a large number of routers and a large number of hosts. And we can only do this by using hierarchical routing, as we just saw. And we use different algorithms based on what type of a network we are using. So in unicast routing, a packet is routed hop by hop by the help of forwarding tables. So we know that every router has got a forwarding table, and based on these forwarding table, we will have the packets moving from one router to the other until they reach their destination. And every router will have forwarding tables inside it that will tell us what is the next router or what hop is the next hop the packet should take. We saw this already. The source host and destination host need no forwarding table because they are inside the same local network and they have the same default router. So routing really means that you take a packet from its source to its destination. And in this case, we are specifically meaning that it is from the source router to the destination router, as we saw in the example here. So the actual routing begins when the packet reaches the source router and the destination router. So the routing will take place during this route. So this was the introduction about Unicast routing. In the next video, we will start looking at the different algorithms.